Hey, what's up everybody? In this video, we're going to go into static variables and methods. So let's get to it. All right, everybody. What you're looking at here is a simple class that I wrote, sticking with our student class. And today we're talking about, like I said before, static methods and variables. So the whole premise of static, the keyword static, is that anything that you declare as static in terms of declaring it inside a class, it means that they belong to the class, but they're not necessarily part of the object. And I'll get to that in a couple of minutes, and you'll understand it once I go through the examples. Okay? So, couple rules. So static variables could be public or private. And it's always going to come after the access modifier. So you have private and then static, and then the data type, and then the variable name. Okay, great. So, and then the other little important thing to remember is that if you declare a variable as static, that variable or method only has access to other static variables and methods. Okay, so if you declare something as a static method, they can't change any instance variable, so it's separate. Okay, and I'll show a picture of this, how we could visualize this happening. So in this case, we have a static username, right? And we have a public method, simple method, and then we also have a getter method for the username. And then we also have just an instance variable GPA, which is you get the return value by doing this method here. Now you'll notice something that perhaps if you caught it, you're probably a little confused. So if you go the other way around, where you have a normal method trying to access, or we'll call this a non-static method, right? So let's mark this as non-static, and then this one as non-static, right? So non-static methods are allowed to access static methods or static variables. Methods or variables, doesn't really matter. Okay, so non-static methods have access to all variables, whether they're instance variables or static variables, and methods, whether they're instance methods or static methods. So in this case, you're seeing a live example where I have a non-static method and I'm trying to access a static variable. And that's okay. So going from that direction, that's all right. Okay? Now, let's take a look at how a little closer look actually to the main. Okay, so before you've been wondering, well, why is the main in terms of the main method and main, or any class that you create, why is it static? Okay, it's static because there could only be one main method. So with static variables, you can only have one, obviously, one copy. Okay, so with any class that you have a main on, your main, meaning your point of entry, has to be static because there could only be one. You can't overload the method. So let's say you try to do some funny stuff and you were trying to overload this static main. You can't do that, right? You can overload anything non-static, right? I can do that. But in terms of the main method, there should only be one, right? So it's got to be marked as static, meaning that the compiler will know that this is the first point of entry, and it knows that by first the name of main, second it's got to be marked as static. Okay, so I hope that clarifies a bit why you have a static void main. Now remember, I said anything that is static, okay, if I had any instance variables within this class, uh, the static methods, or well, let's just say methods, because in this case it's a main method. So the static method, okay, is not able to access or change any values of instance variables, okay, or even in the class itself, okay. And then any static methods cannot call non-static methods inside the class. So if you see here, this class itself, there's no instance variables, no methods, but if I were to add, let us say, just for giggles, right? So int my max number, okay? And then I'll just return 100. So if I were to try and print this out, print line, and then we'll say this dot max number. So this indicates, so here's another little lesson that I did want to go over in conjunction with this. This, when you see this, it means the class that you're in. Okay, so in this case, this represents main. Okay, so if I say this dot max number, I'm calling this method. Okay, now this method is static or non-static? It's non-static, right? It's not pegged with that static keyword. So let's try and run this. So here you see on the right, there's an error, right? So non-static variable, this cannot be referenced from a static context. So when I am in a static method, I don't have access to this, meaning I don't have access to the class main. Okay. Now, that's not to say I can't instantiate objects of other classes, which I'm doing here. That's perfectly fine. But as far as inside the main class, if I'm inside a static method, as I am here, I am not able to access any instance variables or methods of the class. So you see why there's an error. Okay. Now, it'd be different if I mark this as static. So if I did, let's do another because I don't want to confuse anybody. So static int get max number, and then we'll return 200, right? So if I did get max number, we try it that way. That's okay. Right now, the one thing I did have to do is I had to get rid of this, because when I put in this, I'm talking about the class main, right? So by me saying this means the current class I'm in. Now, because this is a static method, okay, because this is a static method, remember what I said in the beginning, static methods and variables belong to the class, but they're not part of the object. So what I'm saying with this is that I'm actually accessing the object of this class. Okay, and because I'm in a static method, I'm not able to use this. And because get max number belongs to the class, and I can access it, then that's perfectly fine. I would just have to call it as get max number. Okay, now let's take a close. So those are pretty much the rules of a static class. The other rule that you can do as well is you can also, if you make, let's say you want to make a public static variable, okay, you can access it by not instantiating an object of a class. So let me show you that real quick. I've declared a static variable, and it's a public static variable. Now, in terms of best practice, this is at least I've used this before. So if you have a static variable and you don't necessarily want to expose it using getter and setter methods, you can make the static variable public. That's perfectly fine. because again, this variable does not belong to the object of the class, it just belongs to the class itself. Now, by me declaring this attend class static, okay, and obviously public, now what I can do in my main over here is I can actually first, because it's public, I can increment it, right? And remember, I'm in a static method, so I'm able to access a static variable, okay? And well, it doesn't really matter, but I don't have to instantiate an object of student in this case. I can access the static variable directly. So what I'm doing here is I'm incrementing it, and then I can also now, if I just call it this way, I can see what the value is. So let me run this. You can see that. And there you go. You see that attendance is plus plus. Now, let's say I didn't even instantiate the object. So you're seeing this instantiation, right? Let's say I did that. Would that still run? I'll give you a second to think about that. Would that still run? Yes, it would run. And you're asking, well, why? Well, remember what I told you. Anything static in a class belongs to the class, but it's not part of the object, right? It's not part of the object itself. So when we say object, it means we're looking at the instantiation using the new operator, right? Here, we can access the attended class static variable like this using the dot notation directly because it's a static variable. Okay, if I tried to do that with a public variable, and I mean the non-static variable, I would not be able to do that because an instance variable that it's non-static belongs to the object. Okay, but a static variable, which is instance static variable, does not belong to the object, it belongs to the class, meaning that I can just say student dot attended class plus plus. I can manipulate it, and then I can also access it here inside here. Okay, so I hope that clarifies why you don't have to create an instance of student. Okay, so that means that I don't care how many instances of student I create because this static variable will remain in memory the whole time my program runs. And this is what I mean. So let's say that after this I said, okay, I'm gonna just do class plus plus, right? And then I will also print that out again, right? Attendance again. So let's run that. Okay, so there you have it. You see that I was able to increment using the increment operator, right? Plus plus. Oops, let's do that. And then I printed it out, and I'm accessing it, and I'm not even creating an instance of this student class, and that's perfectly fine. Okay, as long as it is static. Okay. Okay, good. So now let's look at a picture of this. I want to visually represent this so that you get a big idea. Okay, there's so many rules around this that I think visually would help to look at how things work and how what's actually happening in terms of memory. Okay. Okay, so I hope you find this a little bit enlightening. Okay, just so you understand. I mean, the more you understand about memory allocations and how it works in terms of classes, the better you're going to understand the language itself, and you're going to relate this to other languages. So suppose I have a class on the left-hand side, right? So we're starting out over here. Okay. Now, on class student, we have 4 variables. 2 are instance variables. So these are my instance variables. And then 2 are static. So R and S are the static ones. So the minute that I instantiate, so that's why I said new, right? So when I say instantiate, I mean I'm saying new student somewhere in another class or in the main. When I instantiate an object of the class, meaning a student, I'm actually creating an object in heap memory. So every object in Java is going to be created in heap memory. Okay, so think of heap memory as like somewhat infinite. Don't say that I told you that, but It's not infinite to in terms of you can store whatever you want, but there is a lot of space for you to allocate. Okay, where if you have stack memory, there is a limitation of what things you can store. Okay, so stack memory, think about primitive variables, just int or double, right? And if you go back to the C++ class that I taught, I told you that a lot of the variables that we're declaring are going to be in stack. Okay, but now with objects, they're actually declared along with their instance variables in heap memory. Now with each object that's created, right? So here, what I've done is I've created 3 objects. So if you relate this to code, what I'm really doing is I'm just saying student. I'm on the lower right. Okay, S1 is equal to new student. Okay, and I'm doing this 3 times, except I'm naming the objects differently. So I'll be S2 is equal to new student, and then I'll have S3. Okay, so that's why I created 3 objects. So we'll call this S1, S2, and S3. Now I've created the objects, and what I have now is for each object I have a space for their instance variables. Okay, so in this case we have PQ. We're also going to have a space for methods, okay, in heap memory, but we won't talk about that right now. Okay, so every object is going to have their own instance variables. Okay, so object S1 has their own copy, object S2 has their own copy, and object S3 has their own copy here. Okay, so I hope that that's clear, right? So that means that if S1 modifies P, it's not going to be modified on S2 because they're not sharing instance variables. Okay, they're separate memory space, and S1 is separate from S2 because they're different objects of the class. Okay, now what's happening as well is that student, the class itself, has another area of memory where it's putting the static variables in. So this area of memory is called permgen. Okay, and this is as of Java, I think 8, and I forgot the version, and I read it somewhere in an article. But the static variables are now kept in a memory area called permgen, which is not part of the heap. Okay, it's another area. Okay, and I actually, to think back, I even think that now methods are stored here, but again, I'm not 100% sure. Okay, so R and S are stored in this permgen area, and notice how there's only one block, right? So anybody that comes in and modifies R and S, okay, is going to modify that shared value. So as you saw in my previous program, when I modified that specific static variable, nobody got their own copy. It was shared. So think about it this way. Anybody that comes in, okay, and tries to access the static variables here, they're always going to get the last value, okay, because there's only one copy, okay, in memory. Versus in S1, there's multiple copies. Okay. Now another fun fact, or another thing that you need to realize is that if S1 ever leaves heap memory, meaning that you destroy the object, right, then PQ and all its methods and instance variables are going to go with it. But because I destroy S1, let's put it next here. I love doing. Sorry about the colors. My daughter was playing with with this new tablet that I got. So if you destroy S1, right, and you still have S2, S3, this will not get destroyed. So this remains intact because this is part of the class, not part of the object. So if I destroy this object and this object, this is still alive. Okay, this is still alive. So what does that get you? Like, what are you buying when you use a static variable? Well, if you ever have an issue or a problem where you need to keep a running count of something, or you need to keep something alive in memory, where you know that multiple things, right? So maybe one object 1, object 2, object 3, object 4 need to access that, then you would want to go with a with a static variables. Okay. You also may want to do something with a utility class. So let's say a perfect example is the math class that Java provides, right? Java has this math class, it has a bunch of static methods. When you're doing some type of utility computations, you can keep those as static. Okay, because the computation is kind of, you come in and you come out. You're not really storing any data, right? You're not storing data about something. You are just doing computation and that's it, you're out. Whereas if you have an object such as a student, you're storing data. You're storing the student's ID, you're storing the student's name, right? And that is describing the properties of a student. So when you're describing something about an object, you don't want to make that static. Okay, you don't want to make that static. Versus if you're doing computation, a quick computation, or you're trying to hold on to something that you know is going to be changed, okay, then you want to do a static variable or static method. Okay, at least that's my take. That's the way that I've used it. Okay, so that is kind of the guideline I go by. Okay, that's the guideline I go by. So lastly, what I want to do here is play a game of connect the dots. Okay, so if you look on my left, I have a static method and then instance method. Okay, so we're going to connect as to what we can access. Okay, so a static method can access a static variable. That's okay. And then the static method could also access another static method. That's perfectly fine. But a static method cannot access any instance method or instance variable. So over here and over here cannot do. So remember, instance means object of the class, right? The object. So I can't access anything that is an instance of a class, meaning that once I create the object, right, and you saw that diagram, if you forgot, you can go back, that diagram of where the instance variables could be created in the heap. A static method cannot access anything that's instance. Okay, good so far. So let me erase that. Okay, so you're going to get a compiler error because of that. Now let's go to instance methods. Okay, so this is a little different now. So with instance methods, I can actually access everything over here. Okay, so if I have an instance method, I can access anything that's static. Okay, and if I have an instance method, obviously I can access anything that is instance. Okay, so if we look at my previous diagram here, okay, let's say we created another object here. We'll call this object S3. Okay, we have its own instance variable, so it's going to have PQ. Okay, let's say we had a method in here. I added another method somewhere here. Okay, that can access student. Okay, I'm sorry, the static variables. That's perfectly fine. Okay, that's perfectly fine. What I'm describing here is within the same class. Okay, so don't think that, don't get confused as to, you know, this class or this class. We're just talking about instance methods and variables because we're narrowing down our example to within a class. Okay, so if we go back here, what we're trying to do is we're just trying to give a representation inside a class. If something's static or something's instance, what can access what? Okay, so again, static methods can access anything that's static, so in static variables and static methods, okay? But you see there's no arrow going to instance because I can't access anything that's an instance. But instance actually is kind of like the be all end all, right? It can access static variables and methods, and it can access instance objects and instance variables and methods. Okay. Okay. So again, we're a little bit over 25 minutes, and I hope that you enjoyed the static lecture and you learned a little bit more on how static variables and methods work. On the next video, we'll talk about the inheritance. Okay, we'll start a little bit about inheritance and all that good stuff. At least, yeah, we'll start on inheritance. So I'll hope to see you on the next video.